Hey everyone, and welcome back to the Deep Dives. We're going to be looking at a paper today called FlexTok, Resampling Images into 1D Token Sequences of Flexible Length.
Oh, yeah.
And it's basically about a really interesting new image tokenizer. And it's got some cool implications for image generation and even potentially some other visual reasoning tasks.
Yeah, this is a cool one. So, we're all familiar with traditional tokenization methods where we kind of break up the image into this rigid grid. And, it doesn't really matter whether the image has one object or like 100 objects. You're always going to be stuck with that same grid and the same number of tokens.
That's not very efficient.
Yeah, exactly. Especially when you start thinking about conditional image generation. If you're trying to generate an image from a very simple prompt, like a red apple, you don't want to be stuck processing this huge grid of tokens.
Right.
You want to be able to adapt to the complexity of the visual content.
And that's what FlexTok does.
That's exactly what FlexTok does. So instead of using a fixed grid, it creates these one-dimensional token sequences that can be as short as 1 token or as long as 256 tokens.
Oh, wow. So it's like a sliding scale of detail based on what it needs.
Yeah, exactly. It adapts to the complexity of the image. And one of the things I think is really clever about this is that it uses this Coarse-to-Fine approach. So the early tokens in the sequence, they capture the high-level semantic meaning, like the basic shapes and objects and the overall composition. And then as you add more tokens, you progressively add detail. You start refining the image from a rough sketch to a more fully realized visual.
It's kind of like building with Legos.
Yeah, it's like building a visual vocabulary. Each token is like a different Lego brick representing a different level of detail.
I like that analogy. That's cool.
Yeah.
So, okay, let's dive a little bit deeper here. How does this actually work?
Okay, so FlexTok operates in 3 main stages. The first stage is pre-processing. So they use a pre-trained VAE to compress the image perceptually.
Yeah.
They found that using 16 channels for the VAE latent space gave them the best performance.
And that VAE is very similar to the one that's used in Stable Diffusion XL.
Exactly. Yeah, it's kind of like creating a compressed blueprint of the image before you start building.
Okay, cool. So you got this compressed representation, and then what happens?
All right, so then in stage 1, we get to the heart of FlexTok. So this compressed blueprint then gets fed into a vision transformer encoder. And this encoder is equipped with these special register tokens. And these tokens transform those VAE latents into a one-dimensional sequence.
Okay, well, now what are register tokens?
So imagine them like placeholders that learn to capture the essence of the image as the encoder processes it. They're essentially learning to represent the most salient visual information in a compressed form.
Okay.
And then the output of the encoder is quantized using finite scalar quantization, or FSQ.
Right.
And that turns those continuous representations into discrete tokens.
Gotcha. So we compressed it, we encoded it, we quantized it, we have our tokens now. But how does it decide which information to prioritize when it's creating these sequences?
Yeah, that's the really interesting part. That's where nested dropout comes in. So during training, they randomly drop tokens from the sequence, and this forces the system to learn which tokens are absolutely essential for preserving the core meaning of the image.
So it's like a survival of the fittest for tokens.
Exactly. And it leads to this natural hierarchy of information within the token sequence. Early tokens are packed with high-level semantic meaning, and then later tokens, they come in and add the finer details.
I'm looking at figure 2 right now. It's pretty cool to see how much information can be captured in just a handful of tokens.
Yeah, it's really remarkable. You can see how those first few tokens already define the main subjects and the overall composition of the image. And as you add more tokens, the details get sharper, the colors richer, the textures more intricate.
It's pretty amazing. Okay, so we've got this compressed tokenized representation. How do we get back to an actual image, though?
Yeah. Right, so that's where the Rectified flow decoder comes in. And it's trained on noised VAE latent patches. And it can actually reconstruct plausible images even from those highly compressed token sequences.
Oh, wow.
And what's impressive is that it works well even when you're using very short sequences, meaning you can achieve good image quality with minimal information.
That's pretty cool. And then to help the model converge faster during training, they use this special loss function called RayPA, which uses features from DynaV2L.
Yeah, RayPA is really interesting. It leverages the power of self-supervised learning by tapping into those rich visual features that Dyna2L has already learned.
Right.
So it gives FlexTok a boost in terms of semantic understanding and helps it generate more meaningful reconstructions.
Okay, so now let's move on to what everyone's really excited about, image generation. How does FlexTok perform in this domain?
So they put it to the test by training autoregressive models. specifically GPT-style transformers, to generate images from both class labels and text prompts.
So instead of predicting pixels directly, the model is predicting these tokens.
Exactly, and then those tokens get decoded into an image.
So it's like painting by numbers, but the numbers are these semantically rich tokens.
That's a great way to put it.
And what were the results like?
The results are super promising. On ImageNet, their model achieved an FID score of less than 2 across a range of token sequence lengths, even beating out some state-of-the-art methods that use way more tokens.
Wow, so fewer tokens, better results.
Yeah, exactly. It's very efficient.
What about text-to-image generation, though? How does it handle more complex descriptive prompts?
So that's where the visual vocabulary concept really shines. If you take a look at Figure 6 in the paper, they show examples of images generated from class labels and text prompts using different numbers of tokens. And you can actually see how the image evolves as more tokens are added.
Oh, that's cool. It's like watching an artist gradually add detail to a sketch.
Yeah, exactly.
Starting with those broad strokes and then filling in the finer points.
And the number of tokens directly relates to the level of detail in the generated image.
So if you want like a simple image of a dog, you can use just a few tokens. But if you want a very specific image, like a golden retriever wearing a blue bandana sitting in a field of sunflowers, you might need to use the full 256 tokens.
Right, you need more tokens to capture all those details.
That's amazing. So there's this interplay between the tokenizer and the generative model.
Absolutely, they need to work together.
So what happens when you scale up the autoregressive model?
When you scale up the model, you get better training loss and higher generation quality, especially when you're working with those longer token sequences.
So bigger model equals more detailed, more visually appealing images.
Yeah, pretty much.
Makes sense. So how does FlexTok compare to other image tokenization methods overall?
Well, if you look at Table 1 in the paper, they actually show that FlexTok consistently outperforms other one-dimensional and two-dimensional tokenization methods across a variety of metrics.
Really?
Yeah, it achieves higher reconstruction quality, better generation fidelity. And it does all of this with remarkable efficiency.
Wow, that's really impressive. So FlexTok has the potential to really change things up in the world of AI image processing.
Yeah, I think so. It's a really exciting development.
But before we get too carried away, let's delve into some of the potential limitations and areas for future research when we come back for part 2.
Welcome back. So we've been talking about this really cool new image tokenizer called FlexTok. And while it's super promising, like any new approach, there are always some areas where we can think about how to improve it.
Right. Even the most groundbreaking research, there's always limitations. So where do you see the biggest opportunities for improvement with FlexTok?
Well, one area that really stands out is this sort of delicate balance between the tokenizer and the autoregressive model, especially when you start dealing with those longer token sequences. We talked about how as you increase the number of tokens, that autoregressive model needs to be more powerful to handle that increased complexity.
Right. So it's not just about making the tokenizer better. It's also about making sure the generative model can keep up.
Exactly. Like the FlexTok decoder does a great job of reconstructing images from short sequences, but when you start using those longer sequences, you really need a more robust autoregressive model.
And that becomes even more important as we start thinking about generating higher resolution images.
Exactly. Higher resolution, more detail. All of that requires a more powerful generative model.
So there's a real need to push the boundaries of autoregressive models.
Absolutely. And luckily, there's a lot of exciting research happening in this area, especially with transformer architectures. Finding ways to make these models more efficient, more scalable, that's going to be key.
Now, what about the tokenization process itself? Are there any aspects of FlexTok's approach that you think could be refined?
That's a good question. I think one interesting direction would be to explore the relationship between token length and semantic meaning even further. Right now, FlexTok uses nested dropout to create this hierarchy of information within the token sequence. But what if we could be even more intentional about the types of information that are encoded by different token lengths?
So going beyond just having early tokens represent high-level concepts and later tokens fill in the details.
Right, exactly. Imagine a system where specific tokens are dedicated to representing certain object categories or textures or even artistic styles.
Wow, that's interesting. So it's like giving the AI a much finer level of control over the image creation process.
Exactly. It's like giving an artist a palette of specialized brushes, each one designed for a specific purpose.
I like that analogy. It's like we're moving towards an AI system that can really understand and manipulate visual concepts.
Yeah, and in a way that's more aligned with human cognition.
This reminds me of something we talked about earlier, FlexTok as a visual vocabulary. Are there other ways we can enhance that vocabulary?
Well, one promising approach is to leverage the power of pre-trained models. Think about models like CLIP, which can connect images and text, or Dino V2, which is great at self-supervised visual feature learning.
Right.
These models have already learned so much about visual semantics.
So we could basically give FlexTok a crash course in visual understanding.
Exactly. By tapping into that existing knowledge, we could give it a deeper understanding of objects, scenes, relationships, even abstract concepts.
So that we can move beyond just generating pretty pictures.
Yeah.
And start generating images that actually convey meaning.
Right. Images that are semantically meaningful and contextually relevant.
That's really cool. Now let's shift gears a bit. Let's talk about the applications of FlexTok beyond image generation. What other domains could this technology be used in?
Ooh, there are a lot of possibilities. One that immediately comes to mind is video generation. Video is essentially just a sequence of images, right? So this idea of efficient, adaptable tokenization, that could be super valuable for creating high-quality, dynamic video content.
Imagine being able to generate entire movies from text prompts.
Right. It sounds like science fiction.
It does.
But with FlexTok, it feels like we're getting closer.
We are. What about other tasks?
Well, think about tasks that require AI to reason about the visual world. Things like image captioning, visual question, answering even robotic navigation. All of these could benefit from FlexTok's ability to extract meaningful information from images.
So it's like giving AI the tools to not just see, but to actually understand and interact with the visual world.
Exactly.
That's pretty
It is. Yeah. But, with great power comes great responsibility.
That's a good point.
Yeah.
As exciting as all this is, we need to be mindful of the potential downsides.
Definitely.
And the ethical implications.
Absolutely.
So that's what we'll be exploring when we come back for part 3. All right, so welcome back to the deep dive.
Back again.
We've been talking about FlexTok, this cool new image tokenizer. But as we get into this world of really powerful AI, we got to kind of stop and think about the implications.
Oh, yeah, absolutely. Like the ethical considerations. I mean, as AI gets better and better at creating these hyper-realistic images and videos, we've really got to be careful about how it could be misused.
Like one of the things that I immediately think about is deepfakes.
Deepfakes, yeah, that's a big one.
Like these images and videos that look so real, but they're completely fabricated.
Right, and they can be used for all sorts of bad stuff. Spreading misinformation, manipulating people, even ruining someone's reputation.
And FlexTok, with its ability to generate these high-quality images from minimal input, could potentially be used for this kind of stuff, right?
Yeah, it's a real concern. That's why it's so important that we're already thinking about ways to detect deepfakes and, developing safeguards against them.
And it's not just a technology problem, it's a societal problem too, right?
Oh, yeah, for sure.
We need to educate people about deepfakes.
Definitely how to spot them, how to be critical of what they see online.
Right, exactly. But on the technology side, there's actually a lot of research happening in deepfake detection.
Yeah, they're developing algorithms that can look for those tiny little inconsistencies, those artifacts that are introduced during the generation process.
Like digital fingerprints?
Exactly, like little clues that give away that the image is fake.
But then FlexTok throws a bit of a wrench in things, right?
Kinda, yeah, because remember, FlexTok is all about efficiency. It strips away unnecessary information, so those artifacts might be even harder to find.
Oh, wow. So the deepfake detector is going to have to get even smarter.
They are. It's a constant game of cat and mouse.
Okay, so let's talk about the creative industries.
Yeah.
There's been a lot of talk about AI replacing artists.
Yeah, people are worried about their jobs.
What are your thoughts on that?
I mean, look, AI tools like FlexTok can definitely automate some parts of the image creation process. It's definitely going to make it easier and faster to create visual content.
Right.
But I don't think AI is going to replace artists. I think it's going to augment their abilities.
Like giving them new tools to express themselves.
Exactly. Imagine AI taking care of all the boring, repetitive tasks, and then the artist can focus on the creative stuff.
So instead of fearing AI, artists can embrace it.
Exactly. Use it to their advantage.
But then, of course, there's the whole issue of copyright.
Oh, yeah, that's a big one.
Like if someone uses AI to generate an image based on another artist's work, who owns the copyright?
Yeah, that's a tricky question because traditional copyright law is based on human authorship.
Right.
So it's not really clear how it applies to AI-generated content.
It seems like we need to update our laws to keep up with AI.
We do. We need clear guidelines.
So it sounds like there are a lot of big questions that we still need to answer.
There are a lot of challenges, but a lot of opportunities, too.
It's important that we think about all of this stuff.
Definitely.
The good and the bad.
Yeah.
Before we just kind of let AI run wild.
We need to be responsible with this technology.
And make sure it benefits humanity.
Exactly.
Well, that brings us to the end of our deep dive into FlexTok. It's been a really interesting conversation.
It has been.
We've learned a lot about this new technology. And I think it's clear that FlexTok has the potential to really change the way we think about images and AI.
I agree.
To our listeners, thanks for joining us on the deep dive. Keep exploring, keep learning.
And keep asking those big questions.
We'll see you next time.